we'll understand the concept of swarm. Till now, whatever concept or exercises we have done were all done on a single Docker host. So now we are moving on to the stage in the course where we don't just have one host but multiple hosts. Multi-container, multi-machine applications are made possible by joining multiple machines into a Dockerized cluster, which is called as swarm. A swarm is a group of machines that are running Docker and joined into the cluster. The machines in a swarm can be physical or virtual. After joining a swarm, they are referred to as nodes. So, a node is an instance of the Docker engine participating in the swarm. Production swarm deployments typically include Docker nodes distributed across multiple physical and cloud machines. Current version of Docker includes swarm mode for natively managing a cluster of Docker engines, which is called a swarm. Just as in the case of single container commands or with Compose, we use the Docker command line instruction to create a swarm, deploy application services to a swarm, and manage swarm behavior. The only difference is that now the commands or instructions are all directed to the swarm instead of single container or single Docker host. All the commands are executed on a cluster by a swarm manager. As we see in this diagram, there are multiple nodes joined to make a cluster. We use the Docker engine CLI to give instructions to the commands to the Docker swarms. All these instructions are directed towards the swarm manager. The swarm manager decides which and where and how to execute these instructions. Some important points about the swarm to understand is we use the Docker engine CLI to create a swarm or Docker engines where you can deploy application services. You don't need any additional orchestration software to be installed for the purpose of creating or managing a swarm. Secure by default. Each node in the swarm enforces TLS mutual authentication and encryption to secure communications between itself and all other nodes. You can either use the certificates for the third-party certifying authority or you can use the self-signed certificates of the nodes. Each time a new node joins the swarm, the manager issues a certificate to the node. The certificate contains a randomly generated node ID to identify the node under the certificate common name, that is CN, and the role under the organizational unit, that is OU. The node ID serves as the cryptographical secure node identity for the lifetime of the node in the current swarm. The cluster management and orchestration features embedded in the Docker engine are built using SwarmKit. SwarmKit is a separate project which implements Docker's orchestration layer and is used directly within the Docker. Hello everyone. In this nugget, we will discuss about creating a swarm and adding nodes to it. An entire swarm can be built from a single disk image. You can deploy both kinds of nodes, the managers and workers, using the Docker engine. Docker engine handles specialization about the node role at runtime and not during the deployment time. The role of the node when added to a swarm can be changed as well. A swarm consists of multiple Docker hosts which run in swarm mode and act as a managers or workers. Managers are to manage memberships and delegations, whereas workers' responsibility is to run swarm services. A given Docker host can be a manager, a worker, or perform both the roles. Manager nodes handle the cluster management tasks such as maintaining the cluster state, scheduling services, serving swarm node, HTTP API, endpoints, etc. Manager nodes also perform orchestration functions required to maintain the desired state of the swarm. Manager nodes elect a single leader to conduct orchestration tasks. Worker nodes receive and execute tasks dispatched from the manager nodes. In this diagram, we can see that there are 3 manager nodes and 4 worker nodes. The managers elect a leader among themselves. Managers run as a consensus group. We will see that in the later section. By default, manager node also runs services as worker nodes, but you can configure them to run manager tasks exclusively and be manager only nodes. An agent runs on each worker node and reports on the task assigned to it. The worker node notifies the manager node of the current state of its assigned task so that the manager can maintain the desired state of each worker. When Docker is running in swarm mode, you can still run standalone containers on any of the Docker hosts participating in the swarm, as well as swarm services. A key difference between standalone containers and swarm services is that only swarm managers manage a swarm, while standalone containers can be started on any daemon. I have created a test setup for the purpose of demonstrating Docker Swarm in this course. The requirement for the swarm and my test bed details are as follows. There are 3 nodes in the same network. I have created 3 virtual machines in the Google Compute Engine. Docker Engine 1.12 or newer is required. I have installed the latest version of Docker CE, which is 18.09. We will open following protocols and ports between the hosts. TCP port 2377 for cluster management communications. TCP and UDP port 7946 for communication amongst the nodes. UDP port 4789 for overlay network traffic. These are the nodes used in the test machine. I will just copy the manager node IP address. Okay, and now I will run the swarm init command on the manager node to create a new swarm. On the host, we can type docker swarm init -- advertise address and the manager IP that we've just copied. The advertise -address flag configures the manager node to publish its address as 192.168.99.100. The other nodes in the swarm must be able to access the manager at the IP address. Manager nodes use the advertise address to allow other nodes in the swarm access to the SwarmKit API and overlay networking. The other nodes on the swarm must be able to access the manager node on its advertised address. If you don't specify an advertised address, Docker checks if the system has the single IP address. If so, Docker uses the IP address with the listening port 2377 by default. If the system has multiple addresses, you must specify the correct -- address to enable inter-manager communication and overlay networking. Let's run the command now. As you can see, the output includes the commands to join the new nodes to the swarm. Nodes will join as managers or workers depending on the value for the -- token flag here. The current token that we see on the screen is for adding the worker node. To add a manager node to the swarm, we will run docker swarm join -token manager and follow the instructions. If you don't have the command available, you can run the following command on the manager node to retrieve the join command for the worker. Okay, we'll clear this a bit. Docker swarm join -token and worker. Now let's go to the other worker nodes. I will run the docker join command with the worker token there. So worker node 1, let's run it there now. Okay. Okay, so as seen, this node joined the swarm as a worker. Let's do to the second worker and run the command. Okay, and this node also joined the swarm as the worker. I will run the docker info command to view the state of the swarm. So docker info. As we can see, there are no containers running right now. Docker join worker, the other 2 nodes. But there is one and there are total number of 3 nodes. We can also check the status of the Docker nodes by running the docker ls command. Okay, we can view the information about the nodes. So there is one manager, which is the leader, and 2 worker nodes. All 3 nodes are in the active states, and we can see Nginx version as well. Now, Docker also gives us the option to change the token for adding the worker to the manager nodes. So we can run the command docker swarm join -token -- rotate to invalidate the old token and generate a new token. Specify whether you want to rotate the token for worker or for the manager nodes here. To rotate it for the worker nodes, Docker swarm join token rotate worker. Okay, so now the token has been successfully changed. All the Docker swarm commands can only be run through the manager node. If I go to the worker node now and try Docker node ls, it gives us an error that node is not the swarm manager. So it has to be a manager. Let's go to the manager node again and run the Docker node ls command once again. Okay. The availability column shows whether or not the scheduler can assign tasks to the node. Active means that the scheduler can assign tasks to the node. If we see pause, that means the scheduler doesn't assign new tasks to the node, but existing tasks remain running. And if it is drain, means the scheduler doesn't assign new tasks to the node. The scheduler shuts down any existing tasks and schedules them on the available node. The manager status column shows node participation in the raft consensus. No value indicates a worker node that does not participate in swarm management. Leader means the node is the primary manager node that makes all the swarm management and orchestration decision to the swarm. If this column has a value reachable, it means the node is a manager node participating in the raft consensus quorum. If the leader node becomes unavailable, the node is eligible for election as the new leader. An unavailable value here means the node is a manager that can't communicate with other managers. If a manager node becomes unavailable, you should either join the new manager node to the swarm or promote the worker node to the manager. In this nugget, we will discuss how to inspect an individual node. You can run docker node inspect and the node ID on a manager node to view the details for an individual node. So let's run the docker node inspect here. Docker node inspect, and we will give worker 1. The output defaults to JSON format, but you can pass the -- pretty to print the result in human readable format. So let me run it again with the pretty flag here. Now we can see the details as the host name, when did it join the swarm, the current status, the platform resources plugins, and the certificate details as well. Let's run about adding or removing the label metadata. Node labels provide a flexible method of node organization. You can also use the node labels in the service constraints. Let me clear the screen here first and we will, okay. Now let's run the docker node ls command. Okay. And run the docker node update label, add the manager node to the add label. So let's do that. Docker node update -- label 1 add test 123 on the worker 2. The label add flag supports either a key or a key equals to value pair. Okay, so let's rerun the command. We will make it a key value pair. Say value is 1 2 3 4 5 6, any random one. Now if I do a docker node inspect on this node, let's use the pretty flag with this. Here we should be able to see the labels which are added. Now let's see how to promote or demote a node. Docker gives us a provision to promote the worker node to a manager node. To promote a node or set of nodes, run docker node promote from the manager node. So let's check the help command for this. --help. So as you see, it promotes one or more nodes to the manager node. Similarly, to demote a node or set of nodes, run the docker node demote from the manager node again. All these commands need to be run from the manager node. So let's check the help for this one. Instead of promote, we will use demote. So as you see, it demotes from the manager role to the worker role. Now, let's look at how to leave a swarm. Run the docker swarm leave command on the node to remove it from the swarm. So when a node leaves the swarm, the Docker engine stops running in the swarm mode. The orchestrator no longer schedules tasks to that node. After node leaves the swarm, you can run the docker node rm command on a manager node to remove the node from the node list. So let's go to the worker node now. And first let's check the help for this swarm leave command. So this command allows the node to leave the swarm. There is an option to execute this command forcefully, which forces the node to leave the swarm, ignoring any warnings. Once the node leaves the swarm, we have to delete it from the manager node. Using the docker node rm command, let's check the help for this one first. So as it says, it removes one or more nodes from the swarm. So now let's talk about locking the swarm. When Docker restarts, but both the TLS key used to encrypt communication among swarm nodes and the key used to encrypt and decrypt raft logs on disk are loaded into the each manager's node's memory. Docker allows you to take ownership of these keys and to require manual unlocking of your managers. Now this feature is called auto lock. If the lock is on and the Docker restart, you must unlock the swarm first using the key encryption key generated by the Docker while locking the swarm. You can generate the auto lock while installing the swarm also. Now let's check Docker swarm init help and we can grab the auto lock from it to get the auto lock lines. As you can see, it enables the manager auto locking. If not in the swarm initialization, you can also auto block the existing swarm by running the swarm update command and setting the auto lock to true. So let's do that here. Okay, so docker swarm update -- auto lock equals to true. So the swarm has been locked now and we have been provided by the following key. So let's note it down. We have to note it down somewhere. This key will be using to unlock the swarm. Okay. So a locked swarm causes an error like the following when you try to start or restart the service. So let's try sudo service docker restart. And let's do the docker service ls. Okay, here we get the error that the swarm is locked and we need to unlock it. To unlock a swarm which is locked already, use docker swarm unlock command. So docker swarm unlock, it will prompt you for the key. So let's get the key that we have just copied. Okay, so now let's do the docker service ls command. We see that the swarm is unlocked now. View the current unlock key for a running swarm by using the command docker swarm unlock -key. This gives us the current key. So let's do that. Okay, so here we get that. I can also rotate the unlock key by using docker swarm unlock -key rotate command. Okay. So as you see, the unlock key has been changed. Now I want to disable the auto lock on my swarm. So I will use the docker swarm update -- auto lock equals to false this time. Okay. Using a Raft implementation, the managers maintain a consistent internal state of the entire swarm and all the services running on it. If the manager in a single manager swarm fails, your service continues to run, but you need to create a new cluster to recover. If the swarm loses the quorum of managers, the swarm cannot perform management tasks. If your swarm has multiple managers, always have more than 2. To maintain quorum, a majority of managers must be available. An odd number of managers is recommended because the next even numbers does not make the quorum easier to keep. For instance, now let's see whether you have 3 or 4 managers, you can still only lose one manager and maintain the quorum. If you have 5 or 6 managers, you can still only lose 2, as you can see here in this table. To take advantage of Swarm mode's fault tolerance feature, Docker recommends you implement an odd number of nodes according to your organization's high availability requirements. When you have multiple managers, you can recover from the failure of a manager node without downtime. A 3-manager swarm tolerates a maximum loss of 1 manager. A 5-manager swarm tolerates a maximum simultaneous loss of 2 manager nodes. An n-manager cluster tolerates a loss of at most n-1 by 2 managers. Docker recommends a maximum of 7 manager nodes for a swarm. Hello everyone. In this nugget, we will see how to deploy services to a swarm. Service is a definition of the task to execute on the manager or worker node. It is the central structure of the swarm system and the primary route of the user interaction with the swarm. When you create a service, you specify which container image to use and which commands to execute inside running containers. A task carries a Docker container and the commands to run inside the container. It is the atomic scheduling unit of Swarm. Manager nodes assign tasks to the worker nodes according to the number of replicas set in the service scale. Once a task is assigned to a node, it cannot move to another node. It can only run on the assigned node or fail. Now, declarative service model. Docker Engine uses declarative approach to let you define the desired state of the various services in your application stack. When you create a service, you define its optimal state, that is number of replicas, network and storage resources available to it, ports the services exposes to the outside of the world, and more. Docker works to maintain that desired state. For instance, if a worker node becomes unavailable, Docker schedules that node's task on other nodes. A task in a running container, which is part of the Swarm service and managed by the Swarm manager, as opposed to the standalone container. To deploy your application to Swarm, you submit a service definition to a manager node. The manager node dispatches the unit of work called task to the worker nodes. Scaling. For each service, you can declare the number of tasks you want to run. When you scale up or down, the Swarm manager automatically adapts by adding or removing tasks to maintain the desired state. Desired state reconciliation. The Swarm manager node constantly monitors the cluster state and reconciles any differences between the actual state and your expressed desired state. For example, if you set up a service to run 10 replicas of a container and the worker machine hosting 2 of those replicas crashes, the manager creates 2 new replicas to replace the replicas that crashed. The Swarm manager assigns the new replicas to workers that are running and available. Service discovery. Swarm manager nodes assign each service in the Swarm in a unique DNS name and load balancers running containers. You can query every container running in the Swarm through a DNS server embedded in the Swarm. Rolling updates. At rollout time, you can apply service updates to nodes incrementally. A Swarm manager lets you control the delay between service deployments to different sets of nodes. If anything goes wrong, you can roll back a task to a previous version of the service. Load balancing. You can expose the ports for services to an external load balancer. Internally, the Swarm lets you specify how to distribute service containers between nodes. The Swarm manager uses ingress load balancing to expose the services you want to make available externally to the Swarm. The Swarm manager can automatically assign the service a published port, or you can configure a published port for the service. You can specify any unused port. If you do not specify a port, the Swarm manager assigns the service a port in the range 30,000 to 32,767 range. External components such as the cloud load balancers can access the service on the published port of any node in the cluster. Whether or not the node is currently running the task for the service, all nodes in the Swarm route ingress connections to the running task instance. Swarm node has an internal DNS component that automatically assigns each service in the swarm a DNS entry. The swarm manager uses internal load balancing to distribute requests among services within the cluster based upon the DNS name of the service. Okay, so let's go back to our host. On our swarm, let's deploy a service based on the Nginx image. I want 3 replicas for it. So let's run the command docker service create -- we want 3 replicas, name, and we will use test nginx. Okay, nginx. The argument defines the service. Okay, so let's run it now. Okay, so now it is running. We can see that all 3 instances are running. Let's see these services. So the service test nginx has been created with 3 replicas. Okay, so we can run docker service inspect with pretty option on it. So let's do docker service inspect -- pretty and the service ID to display the details about the service. Okay, so you can see that the service mode is replicated. Replicas are 3. Parallelism is 1 for the update config, and it gives details about monitoring period and the container specifications. If you now run it without the pretty flag, it will show you in the JSON format. You can use the docker service ps to see which nodes are running in the service. So let's do that. So docker service, we can see that here that one instance each is running on all the 3 nodes. There is an instance which is running on manager node as well. By default, manager node in the swarm can execute tasks just like the worker nodes. Swarm also specifies the desired state and the current state. So we can see that the desired state is running and the current state for all the instances are running. As we know, containers running in a swarm are called tasks. We can run docker ps on the node where the task is running, and it gives details about the container for the task. So let's go ahead and run the docker ps. Okay, on this host we will say docker ps, and we can see that the nginx container is running here. Now let's talk about scaling a service. We can increase the number of instances or decrease it as required, which is known as scaling. Run the scale command to change the desired state of the service running in the swarm. So let's do that. Okay, we already have nginx swarm which has 3 running instances. 1 instance each is running on 3 nodes. So let's increase the number of instances to 5 now. So docker service scale test nginx equals to 5. Okay, it is running. Okay, so docker service ps test nginx. You can see that swarm has created 5 new tasks to scale to a total of 5 running instances of the service. Now let's decrease the number of instances to 2. Docker service scale test nginx equals to 2. Okay, hit enter. Now you can see that the test nginx instances have been reduced to 2. We can confirm this by running docker service ps for that service name. Previously we had couple of instances running on the manager node. Now there are none. Now let's check number of containers running on the manager node. Okay, so docker ps -a, we see that there are none and previous instances are now cleared. We can also delete the service from the swarm. So docker service rm, and we will use the nginx name. Okay, so upon running, the command will start removing all the running instances from the swarm. It takes a little bit. Now let's run the docker ps-a to verify. As we can see, all the running instances of the service are removed.